Right, so can you guys see my screen now?
Yes, sir.
Yes, sir.
All right. Okay,
I said
so
I
I
want to disturb you. I'm not taking no for an answer today.
what? What is that, Mr. Palababa?
Nothing, sir.
All right. Okay then. So I hope that you guys have already checked some of this. So I've just added this one right now, LT Spice application, because this is the application or software that we're going to use for your laboratories. Right. So is there anyone here who has an idea about LT Spice or what is this LT Spice? Have you guys heard of this one? Or
Di po,
is
sir.
No, sir.
this new to you guys, most of you, or all of you? This is your first time learning about this application. Am I correct?
Yes po.
All right then. So don't you guys worry. This one is user friendly. Okay? It's quite easy to use. All right. So I would like you guys to download it now. Okay. So I put here the link. So just left click this one. Then it will lead you to this interface, and then just click this download link of LT Spice 17. Okay. And then it will lead you to this website. So just click this download. Okay. So this is one of the updated application that or versions of LT Spice that you can download on the internet. So this one was just updated 2020. Okay. Some are LT Spice 7, LT Spice 15, we even have 16, and then this is the latest one, LT Spice 17. All right. So while you guys are downloading that one, I've also included here some of the shortcut keys. Okay. So if you click this one, it will give you this PDFs. This is one slide PDF only. Okay, so just wait here. So as you guys can see, we have here all of the shortcut keys that you need to know once you're inside of the LD Spice application. Okay, so mostly they are in F buttons, F1, F2, F3, and so on and so forth. And then some are with Control Z, but Control Z here is not the undo. Okay, this one is the zoom area, and then Control B is for the zoom back, and space is for the zoom fit. Okay, so they are quite untraditional or the not traditional way of doing things. So if you want to undo things or like Control Z, you have to click F9. Okay, so it's quite far with what we used to be, in other applications. Okay, and then for redo, we have Shift and then F9. So you really need to use your two hands, okay, if you want to redo something. All right. So I would like you guys to check this one. Okay. So you're the ones going to analyze this one. Anyway, so just check this one schematic and then the symbols. And then for the place, you have to know that these are the shortcuts for resistor or for capacitor C. So this one is quite straightforward. So no problem when it comes to this one. Okay, but for inductor, it's not I, okay, but it is letter L. Okay, and then the rest, I guess, yeah, they are starting with the first letter. Okay, the name of that component, G ground, P text, etc., etc. All right, so that's it for the shortcut keys, and then we have here the, a little guidelines. This is just a short introduction about Spice and what are the things. Oops. Oh, I wasn't able to upload the other one. Okay, let me just update this one. I have uploaded the same file. So the other one should be the guidelines, okay, not the commands. Where is that? This one, LT guide. Okay, so here's the guidelines. So please check this one also. So in here, it will give you, a brief idea on what are things that is inside of our LP Spice. Like it will discuss here resistors, capacitors, ground, the wirings, and the other components that you'll be needing. And then for the units, okay, like do you need to put a capital letter M or small letter m for megahertz? Okay, so it will be discussed in here. Okay, and then other label components, label nodes, and then if you want to put some text or comments, so it's in here. You want to delete, you want to move, to copy, to mirror, etc., etc. So I would like you guys to read this one. All right. So yeah, that's it for the application that we're going to use. And then let's now move on to the syllabus. Okay. So basically, the syllabus of this one is based from the lecture itself. It's just that, as you guys can see right here, it's more on experimental determination of the characteristics of different circuit. So of course, came from the vector, so from the series to parallel, series, parallel, parallel series, delta and y, and the kinds of theorems, Kirchhoff laws, KVL, etc., etc. Okay, so in here we're just going to apply what we've learned or what you guys are going to learn in the lecture. Okay, and what else? So for the course learning outcomes, so of course you must be able to familiarize the regulations and rules when it comes to electrical engineering laboratory. So this one is actually based from the laboratories of electrical engineering, since they are the ones mostly using this kind of experimentations. Okay, so safety precautions. So what are things that you need to do? But since we are not in actual laboratory, so I won't be able to show to you guys what are the things that you should and should not do. So if you want to experience, is this really right? Is this really correct? So I would like you guys to search the things that you should do and should not do when you're inside of the laboratory. Okay. So some, wear gloves, some wear lab gowns, but easy, I think it's not needed. But in some cases, they need lab gowns. And then, the rules in performing a laboratory experiment. Okay. So everything will be taught inside of that classroom. So what are things that you should do and should not do? Well, supposedly I will be reading that certain manual, but since we are not in UC right now, so I won't be able to share to you guys the rules that you need to know if you are inside of a laboratory. So I hope that some of you or most of you have already visited the laboratory of electrical engineering or electronic communications engineering in UC, so that you guys have an idea what it looks like on how they experiment or what are the apparatus that they are using. Okay, aside from the voltmeters or the digital multimeter, the resistors, capacitors, etc. So instead, just the basics. And what are the other advanced tools that we are using aside from those basics? And then, of course, supposedly familiarizing or familiarization of that equipment or apparatus that you're using. But then again, since we are not inside of UC, so it's likely 1 to 5 is already gone. But don't you guys worry. So we are now in virtual or online. So we have a lot of software to simulate those experiments. Though some of them are really impossible unless you do it in actual. But some of them is still doable with the use of a software, which is the LV-SPICE 17. All right. And then for the course content, so as you guys can see, this one also came from the syllabus of the lecture. So week 1 to week 3 is will be covered up to the power, heat, and light. Okay, and then for the week 4 to week 6, so this is where you're going to start for the series resistive circuit and parallel resistive circuit. So in here, that depends. If you guys are already done with these topics, then we may proceed up to week 4. Okay, and then the remaining time for the remaining topics will be discussed on finals, so that you guys can have more time in finishing your laboratories and finals. All right. And then we have here the available ebook. Well, this is not actually an ebook, not a complete guideline, but just a short or introductory guideline only, not a full course ebook. Okay, so this one is the same, just like what I have uploaded a while ago. Where is that one? The same with this one. We have here the commands and then the LT guide, okay, or LT Spice guide. So yeah, it's the same with this one. And then basis of evaluation, so the same. Grading system, the same. You guys already know that one. And yeah, so that's it for the syllabus. So you guys have a clarification so far?
None, sir.
How about the others?
None,
Wala
sir.
po, sir.
Okay, sir.
All right then. So let us now move on to the overview of your week 1, module 1. Okay. So as you guys can see right here, the title is resistance measurement by meter and color code. Okay. So supposedly you will do this one with the use of volt meter or the DMM or digital multimeter. But since we are in online distance learning, we will only do the color coding. Okay, so you guys can, or anyone can do this one, okay, as long as you know or as long as you have memorized the color code and then the values next to it, and then the process, of course. We have a process on how to determine the resistance value of a certain resistor. Anyway, before that, so let me just, show this one to you guys. So for the topic learning outcomes, so it's very straightforward. So number one, we are here right now to determine the resistor's resistive value. Okay, so that is our main goal actually. And then determine the percentage of tolerance. So this is the second one. If we have the resistive value, it has an equivalent tolerance. Okay, so it could be positive minus 5%, positive minus 10%, and so on and so forth. That depends on the resistor's value. So with physical size of the resistor indicating its wattage rating. And then lastly, determine different color bands and its equivalent tolerance. So as you guys can see, this is just like a summary of number 1 and 2. Okay. So once you're done in determining the resistive value and then the percentage of tolerance, so indicate the 1 by 1 or the different colors of that resistors. Okay. And then the equivalent tolerance of those 3 different color bands. Okay. And for the list of topics, so this one actually came from the instruction of your laboratory number 1. So in here, we're going to talk about the reasons why you need to measure resistance of a resistor. And we're going to talk about the easy way to measure a resistor. And of course, if we have easy way, we also have the not so easy way. So it's still easy, but it's a little bit harder. Okay. And the last one here is determining resistive value and its equivalent tolerance. All right. And then for the lecture presentation, so of course we have here the PDF or the instruction itself for your laboratory number 1. And we have here some video materials. So I have prepared 3. Okay. So the first link will teach you on how to use a digital multimeter. So this one is in English version. Okay, the first one, letter A. But for the letter B, to those who cannot still understand after watching this one, so you can watch letter B. So this one is in Tagalog version. Okay, the one who's speaking here is Filipino, of course. Okay, and this one is also in Filipino. Okay, title. And the last one here is how to read a resistor by its color code. So this is actually our main concern. So supposedly you will do this one by BOM and by color coding. But since we are not in UC and then you guys do not have your own voltmeter, you guys do not also have your own resistors, and you guys do not also have the say power supply. Okay, the other things that you're going to need for this laboratory. So we're just going to read the resistor value by color code. Okay, so just click this one and then it will lead you to a video tutorial. So this one is, I guess, 5-minute video. This one is 10 minutes, and then this one is 3 minutes. So those are, super short tutorials. So please visit them for you to have an idea how to measure a certain resistor. Okay, and then we have here the reading materials for the resistor color code chart. So this is just a basis for you guys to see that we have 4 color bands. This is the normal one. We even have the 5-band color, which is rare. And then we even have the 6-band color code, which is much rarer. Okay. So as you guys can see, this one has a tolerance of 276. This one has a tolerance of 47.5. This one has a tolerance of 10K. Okay. So that one depends on the combination of the last band. Okay, not on the I call this one the arrangement. Okay, because most of us will think that the 4th band will dictate the tolerance, but that depends on the counts of bands. Okay, like in here, the 4th band is still the multiplier. It's not the tolerance part. Okay, and for the 6-band color, you need to consider 2 bands for the tolerance. So, sir, what are those tolerances that you're talking about? So later on, okay. So I'll teach you guys on how to measure a resistor by using a color code. Okay. But for now, so let's just finish the overview of your module 1. And lastly, for the references, so most of my instruction or the information actually came from All About Circuits. So just click this website, then it will lead you to this website, of course, All About Circuits. So as you guys can see, we have here a calculator for 4-band resistor, 5-band resistor, 6-band resistor, and so on and so forth. So just by putting the colors, okay, first digit, second digit, third digit, fourth digit, you already know the resistance, the tolerance, the minimum, and then the maximum tolerance of it. But of course, we're not going to do the experiment by doing it on calculator, okay? Since if you do that one in calculator, so where is the learning part? Okay, you're just only, you call this one, you're only, what is the English of niloloko? Niloloko mo lang sarili mo. You're only fooling yourself, okay? So please do not cheat yourself. Instead, please learn to, do the hard way and then learn it the slower way. Okay? In that way, you'll be able to understand the topic a little more. So yeah, the faster, the better, but in some cases, slower, the better, okay? Especially in learning. All right. And then here are some explanations about resistor band colors. So we have here from black to white, and then it's ranging from 0 to 9, etc., etc. So later on, we will discuss those. Okay. All right. So yeah, that's it for the overview. So let us now move on to the instruction of your laboratory number 1. Okay. So download this one now so that you guys can have your own copy, since I will just give you guys the summary of this one. So I will not read everything. Okay, so just in case you want to go back on that part, so you can read that one on your own copy. Anyway, so resistance measurement by color code. So I'll update this one soon, since you're not going to measure the resistance or resistor by meter. Okay, it's only by color code. Okay, so description. So the resistor is the fundamental electronic component that is resisting the flow of electrons in a simple and predictable way. So a resistor allows the designer to easily manipulate currents and voltages, and currents and voltages are what circuits are all about. So I hope that all of you already know what a resistor do in our circuit. So it limits, okay? It limits the current in our circuit. It's like, instead of having 5 milliamps, if you make your resistors higher, and as you guys you all know, it will lessen also your current. Okay, so the higher the resistance, the lower the current. The lower the resistance, the higher the current, of course. So the only proportional variables is the voltage and then the current. But for the resistors, so the higher the resistors or the higher the resistance value, the lesser or the lower the voltage value, and then the lesser the current value. All right. So before you measure, this is one thing that you need to know, which is already common sense. So why do we measure a resistor? Okay. So in some ways, maybe the colors or the color bands of that resistor is already gone, or it's fading, like it's not clear anymore, like you're not sure if this one is orange or red or brown, okay? Especially if you're a little bit colorblind, or if you are really colorblind. So that is one reason already on why you need to measure a resistor. Or let's say you're looking for a certain value of a resistor, and you're lazy enough not to check the color bands, especially if you don't know how those color band works. Okay, so you just use your VOM and then measure. Okay, this one is 1K. Okay, this one is 10K. Okay. But don't get me wrong, so you guys might be shocked. In reality, that 1K is not exactly 1K. Sometimes it's only 980. Sometimes it's even exceeding to 1010. Okay, so that's where tolerance is coming from. Okay, so it's not exactly 1K, but close enough. All right. And one more thing here is, second is, you may need to know the exact value of a specific resistor, not the nominal value. Like for example, you already know that this one is 1K, but you still want to know the exact value of that one. So you might want to check it using a voltmeter. Okay, so that is another reason on why you measure a certain resistor. And of course, you must know the law, okay, before you do such thing. You must know that we have this formula: V is equal to I times R. Like what I've said a while ago, the higher the resistor, the lower the voltage and current. Okay, and vice versa. Okay, and then we have here the easy way. So the easy way is with the use of digital multimeter. So just by putting this probe end to end, and then you will already get the reading. Okay, that's the easy way. But we also have here the not so easy way, okay, wherein, let's say, it's already inside of a circuit. Okay, so you cannot just get the resistor and then measure it, and then there's other components inside of it, like there's a bulb, there's another resistor here, there's another capacitor here, so you won't be easily get the value of that resistor. But instead, you need your knowledge when it comes to Ohm's law. Okay, so you must know this, like R is equal to V divided by I. So you must get the individual current, individual resistance, for you to be able to get the entire individual values, or the entire resistance or entire current. Okay, so that depends on what we are solving. Okay, and then one more thing. So if you want to measure the complete voltage, or complete resistance, or complete current, so it must be from end to end, like it must be a between switch, like this one right now is in an open switch. Okay, so that all of your currents will flow to your DMM, or digital multimeter, and then we'll go back to the ground. Okay, because if we have this line here, it's like you are now forming a parallel circuit. Okay, so some of the currents will still flow here, and then some of the currents will flow here. Okay, so it's only possible if we are measuring this one in series. But what if this one now is in parallel, like this one is in a closed switch? So we have to consider that one also. Okay, so it must be in one loop only if you want to get the total resistance, total voltage, and total current. All right. And here's another scenario wherein you need to know the VR unknown, okay, but you know you know one resistors, but you don't know the others. So for you to be able to solve this one, you have to solve for this one first. All right, so yeah, that's it for the scenario. We have the easy way and then not so easy way. So the not so easy way is, of course, with the use of Ohm's law. But what if it's just the resistor, okay, which is our main goal in this laboratory number 1. So our resistor is not connected yet on a circuit. Okay? So for us to be able to know the value of this one, you have to know, okay, or you must know the color coding method. Okay, so what is this color coding method? So this is what we use to know the values of an individual resistor. So as you guys can see, this one is just a 4-band resistor. So we have the green, black, and then red, and then gold. So don't you guys worry. So this red might be orange to you guys, and then this gold might be yellow to you guys. So I put here the exact or specific color of that band, okay, for us to have a common answer. Because before, when I gave this one to them, some of them think that this one is yellow. Some of them think that this one is orange. Some of them think that this one is gold. So there's a lot of different answers. Okay, so for us to have a uniform answer, so I've already included here the label on each of those colors. Okay, and so on and so forth. So as you guys can see, we have 10 resistors here. 10 resistors where you need to measure the value of that one and then the tolerance. Okay, so here's how to answer. Okay, so any questions so far before I discuss on how to answer those 10 resistors? Do you guys have any clarification?
Wala po,
No.
sir.
None, sir.
Wala pa naman, sir.
Okay, so this is the last part, but this last part is the most important. Okay, so pay attention. So how to answer, refer to this picture only, okay? So let me tell you this one, you guys. This picture is maybe different in other pictures where we have on the internet right now, okay? Like some of the pictures, like the brown here, is the tolerance is like 1.5%, but in here it's 2%. And some other picture or graph, we have here 0.5%, but in others, they don't have a tolerance for the green. Okay, so for you guys to have the correct answer or correct value, just refer to this picture. Okay, so do not also use calculator. So that calculator might have a different calculations. So just refer to this picture only for you to be able to get the correct answer. Okay, so all right, let's now move on. So as you guys can see, this one is first digit, second, third, and then fourth. So for the first 2 digits, okay, first digit and second digit, so all you need to know is the equivalent value of that color. So like for example, we have here green. Okay, so just look for green for the first digit. So it's 5, and then we have here black. So the second digit is black, which is this one. So 5 and then 0. So just concatenate those two. So put them side by side. So 50, which is now 50. Okay, and then the third one is your multiplier. So multiplier, from the word itself, we have to multiply it from the value of this one. Okay, so 50, we have here red, okay, which is a value of 100 right here. So 50 times 100, 50,000, right? So guys, can you guys still follow?
Yes, sir.
Yes, sir.
So we have here 50 times 100 is equal to 50,000. Am I correct? Or 5,000? 50,000. Okay.
5,000 yata.
5,000, sir.
5,000, sir.
5,000 only. Okay. So, all right. So this one 5,000 or 5K. Okay. And then the last one is our tolerance. Okay. So when we say tolerance, it is a positive and minus value. So like for example, this one, we have here a tolerance of 2%. So we have 5,000. So just get the 2% of it, which is, what is the value? 2% of 5,000.
100, sir.
100. Okay. My brain is not working right now. Anyway, so the tolerance of that resistor, so green, black, red, and then brown is 50,000. 5,000 of value, and the tolerance is positive 5,100, and then negative 4,900. So as you guys can see, it might be ranging from 4,900 to 5,100. So that's the variation. Okay, so you can say that it's call this one factory default. Yeah, something like factory default. Like supposedly they should be providing us at exactly 5,000, but in some cases it's only 4,900 or even 5,100. So as long as it's inside of those, it's okay. Okay, so it's not really reliable that if it's 5,000, okay, it's really 5,000. Sometimes it's 4,950, sometimes it's 5,050, and so on and so forth. Okay. So yeah, that's how you measure, not really measure, that's how to determine, okay, the value of a resistor using a color coding method. All right, so were you guys able to get that one?
Yes, sir.
Yes, sir.
So
Yes,
let
sir.
me give you guys another example. If we have, let's say, gray and then violet, so that's 87, and then we have a multiplier of black, so 87 times 1 is 1. So 87 ohms is the value of that resistor. And then let's say we have a tolerance of 5%. Okay, so yeah, the value of that one is ranging from this to this. Okay, just get the 5% of it. So plus and minus. All right, so yeah, that's it for your laboratory number 1. So later on, we will discuss on how to use the LT Spice 70. So I hope that you guys have already downloaded it and then installed it on your computer. So, yeah. So we'll just continue the rest on the part 2. Okay. So goodbye for now, and then see you guys later on for the part 2.